Linear and nonlinear relations. Our goal is to determine if a relation is linear or nonlinear. From a graph, linear relations have graphs that are straight lines. So on the left, we have a linear relation, and on the right, a nonlinear. From a table of values, in linear relations, values of y increase or decrease by a constant amount as values of x increase or decrease by a constant amount. Horizontal and vertical lines are exceptions. So if we look at the linear relation, as we increase 1 each step in our x values, our y values increase in each step by 3. In a nonlinear relation, our x values can be increasing by a constant amount, but if we look at our y values are increasing by a changing amount, and therefore it'll be a nonlinear relation. From an equation. When a linear relation is written as an equation, it will contain 1 or 2 variables, and its degree will be 1. So examples of linear relations can be something like x equals 7, 3m plus 2n equals negative 12, y equals negative 2/3 x plus 5. Nonlinear relations. Our first example is 2x plus y squared equals 6. So because of this squared exponent, it is nonlinear. H equals k cubed. Again, it has a degree higher than 1, so it will be nonlinear. X times y equals 3. Again, this will be a nonlinear relation because we cannot multiply our 2 variables together and still have a linear relation. From ordered pairs. A linear relation will have ordered pairs where the first coordinates will increase or decrease at a constant rate as the second coordinate will increase or decrease at a constant rate. It is important that the first coordinates are listed in numerical order. So although it doesn't matter when we're listing those just as a set, if we're trying to decide if it's a linear relation, our x values have to be listed in numerical order. So if we look at the jump in x values, each step in this linear relation increases by 100. We then need to check our y values. So that increase in each step is 20. Both of them increase by a constant amount, so it is a linear relation. Consider each relation. Determine whether the relation is linear. Explain why or why not. So this relation is described by, so it's a set of ordered pairs. Need to make sure those ordered pairs are in numerical order, and they are. And then I want to look at the changes in each of those x values. Whoops. So we want to look at what happens in each of those jumps. So from negative 9 to negative 7, we've increased by 2. Negative 7 to negative 5 is also an increase by 2. Negative 5 to negative 3 is going up by 2, and negative 3 to negative 1 is going up by 2. Then we need to check our y values, so checking each of these jumps. Negative 10 to negative 5 is increasing by 5. Negative 5 to 0 is up by 5. 0 to 5 is up by 5, and 5 to 10 is up by 5. So yes, it is a linear. The graph shows the relationship between the amount A of radioactive isotope present and the age of a rock sample over time in years. This would be a non-linear relation because the graph is not a straight line. The relation described by the equation m minus 17 equals 0.8m. If this one would be linear, it has 2 variables, but they are not being multiplied together, so that's all right. And the degree of this equation is 1. When we're talking about degree, remember we're looking at the exponents. Which relation is linear? Justify the answer. A new car is purchased for $24,000. Every year, the value of the car decreases by 15%. The value is related to time. So in this question, this would be a non-linear example. And why is because it decreases by 15% of the new value. And so the value of that car changes every year. And if the value of the car changes each year, then the value, 15% of that will be a different amount. For a service call, an electrician charges a $75 flat rate plus $50 per hour. The total cost for the service is related to time. So we could use this equation to represent. Here's our flat rate plus $50 per hour. This is a linear relation because as our number of hours increase by 1, the cost is going to increase by $50. Match each linear relation with possible representations in the selections that are given. Justify your choices. So part A, the pressure that a scuba diver experiences underwater as a constant rate relative to the diver's depth below the surface. So we're looking for something that relates pressure and depth. And so our graph down here at C would be a good match for situation A. As the pressure increases, the depth increases. What's wrong with part D? It's also a pressure depth. But in part D, our graph is not continuous. It's not connected by a straight line. So that means that we would actually jump from one depth to the next depth. Part B, y equals 1/2 x plus 4. We have a couple of situations that would match this one. Can you find them? The first one would be part E. One number is half of another number increased by 4. So here's half of our number increased by 4 is the add 4. So part B would represent it as in words. We could also match it up with the graph from part A. So graph A would also match part B. If we look at any of those numbers, so for instance, if our x value is 0, our y value becomes 4. If I substitute 0 in for x, 0 times 1/2 is 0, plus 4 is 4. And I could check that for each value or for a series of values to confirm that that graph also matches that equation. Okay, try practice number 1.